Good morning, everyone. Happy New Year. Wish you all a Happy New Year. Hope 2021 is much better compared to 2020. Okay, so we will start this new year with one of the most common discussed topics and one of the demanding topics also. Many people ask this from the interview perspective, design patterns and then dependency injection. In fact, we will combine them in the talk. It will be like two different topics, but actually the ways I will swap in between to make sure that we go on the flow. So I'll just switch some topics in between actually. So basically, we are going to discuss about dependency injection and design patterns that are specific to those dependency injection related items. That's how we will keep it. Not as usual in Bojek, it's more of a dialogue where you can also stop in between, you can ask questions, we can discuss, debate, and that's how we learn effectively. That's the idea. So stop me, discuss anything in between also, no problem. So now we'll start with dependency injection. We'll talk about dependency injection. I would like to get from audience different perspective, like why do we need dependency injection in practice? What is the necessity of going with dependency injection?
Chaitanya here.
Yes, yes.
So dependency injection is like something it is a norm for today. Nobody creates any dependencies hand-coded now. They always use some framework. So it's like everybody now is used to dependency injection.
Correct. So who is this?
Chaitanya.
Chaitanya, excellent. In fact, this is exactly what I wanted to initiate actually. So now there are certain things that we take it for granted. We use it daily, so we do not even know how it comes and what are the things that we can do. This points is that when we talk about dependency injection, most of the time we consider that, okay, dependency injection means it is spring. It's not just spring. There are a lot of other things also. In fact, you can create your own way of dependency injection. So I just put two items together here. Before we go there, we will just get answers from some of our other friends also. For example, Naidu M said it's loose coupling. Yes, Naidu, that is correct. And then Shivakumar has given an answer like for pluggable system, he would prefer dependency injection. Basically, both same actually. So we want to, bottom line, let us go to the object-oriented way of thinking it. Okay, bottom line, the objects, we create objects. The most powerful feature of object-oriented language is the new operator. And when the power is there, power comes with more responsibility also. So we should not just create new everywhere. We need to have that control of how we create stuff, how we can customize the creation. Because most of the problem, if you think, if you solve it at the creational level, there are objects that are getting created. Then they get into the behavioral mode and they have a structure. So that's what design patterns will be structured. Creational pattern, structural pattern, and then behavioral pattern. So the most fundamental unit is creational things, because the more control that you have right at the time of creating objects, you'll have better control. Good start is always a 50% good finish. That is what we'll consider. Okay. Now, how are we going to create objects? That's the place where these kind of things comes into picture. Let us just consider what we were doing just before this dependency injection frameworks came into mainland. Did we not doing this? Is it like we did not do this dependency injection at all? No, we did that with one of the most commonly used design pattern. Can anyone tell me what is the design pattern that is most of the time related to dependency injection? Okay, one is builder. Builder is like builder. We can say, okay, you create an object with multiple stuff. That's builder. Okay. Factory pattern, excellent. Okay, so factory is the pattern that we use. So factory, let us consider that factory is not a technical word. Let us consider what is the factory that we mean in real time. Okay, for example, you have chips. You can make chips right at your house also. You can make it on your own. But there are chips that are made in factory. What is that required is the nice way of packaging. How do we distribute it? Everything is considered right inside the factory, and that's why you need a factory environment. So your chips are created in factory, and then you get through package. That is one way of looking at it. Okay, so factory is a controlled environment. That is what we consider, right? Okay, now enough of theory. We will get into the code now, which is the fun part now. So now what we are going to discuss now is we are going to discuss about multiple way of doing dependency injections. One of the most commonly item is nowadays we use Spring, which will do dependency injection, where it will just load objects for you. You don't need to create the dependencies. You can just auto wire them. That is how you create it. But one interesting aspect that, so now before we go to the today's topic, let us understand how Spring works. So now in Spring world, your dependency injection is done at runtime. So what it means is, let us consider the existing assumptions of Spring World. So in Spring World, you do dependency injection. So how do you do dependency injection in Spring? Is it is done at runtime. When we say runtime, what is the facility that we will use to create dependency injection at runtime? Let us consider two cases. For example, you might need to call setters and getters, because that is how you will create objects, right? So at runtime, it might need to call the setters and getters. In that case, Spring use reflections. So we all know what is reflection. Reflection is kind of a dynamic behavior where you will get the class metadata. You can invoke method dynamically. That is reflection. And the other thing that Spring will use is it will use a feature called dynamic proxies. So for example, if you consider your repositories case, you will create @component @repository. But repository, if you note it down, it will be an interface. It's not actual class. So what is the magic that Spring does is, right at the startup time, so Spring gets through your hierarchy. In fact, if you are using Spring Boot, it is scanning also. You don't need to configure it. It scans your code base, get the modules, and then process the annotations and fill all the setters and getters, and then create proxies, and it prepares your dependency injection environment. Finally, it creates something called application context. So this is Spring World. I hope this everybody is familiar with. In case if anybody is missing this, any one of this, let me know, because we'll build from here. So what happens in Spring case is, during the startup time, during the startup time, basically it's a runtime. What Spring does is, it will use the setters and getters to put these objects through AutoWire, and then also it uses a technique like the dynamic proxies, where you define interfaces and it creates concrete classes right at that time. So how it does that is, it actually scans your class paths and then identify all that is required. And finally, the end product is, we will create an application context. And through this application context, you can AutoWire an application context also. That also is a bean. You can see that application context will have methods like get bean of type. So this is how the Spring Boot, Spring MVC, all the framework that you see, they work with this. This all comes from, I think, this project called Spring Core. Okay, this is about Spring World. Now, what is new coming is, nowadays people are thinking this is ideal, this is perfect, okay? But only one thing that people consider a little scope for improvement now. The reason being, the point that we need to avoid here is this. Okay, let us consider the world before Spring. In those cases, we were using factory pattern. Even today, you can use it. If you do not want to use any specific framework, you can write factories. Even in core Java, there are a lot of factories. I think data format is a factory. Date format is a factory. Simple date format or something like that. There are some factory patterns built right in our core JDK itself. So they do not work with any frameworks. In that case, your responsibility is you will write lot of boilerplate code, and that is the problem that we had in the previous world. So this is world number one, and then this is the next gen. Now we are going to talk about the next item. So in order to solve this lot of boilerplate code, only Spring started doing it, and it is quite effective. And it keeps all this complexity under the hood, so you don't even see. You will write less code. That is always what we want to do. We will write less code, and then Spring does most of the items behind the screen. Okay, it's all working fine. But nowadays, we are getting into more demanding nature. For example, if you are using Java to create Android app, or you are using Java to write, for example, a serverless app. Okay, these two applications has a unique requirement where something, if this is all fine, they need all this, but they have a concern on these two steps. Can anyone tell me what is the concern if I'm developing an Android or serverless application considering these two? So maybe I will give a clue. So what happens in dependency injection world in Spring sense is that during your startup time, Spring will scan your class path, understand what are the dependencies that you want to create, and then create necessary steps using reflections and dynamic proxies and prepare an application context. So there is a preparation that is happening. There is a prep work happening at the startup time, or sometime runtime if you are doing lazy. So startup time, let us just take, even I will give a relatively better. Is there any problem that we have when we consider these two applications. As an application user or as a serverless developer, you want your application to start early, finish early. Okay, that startup time matters a lot in these cases. It may not matter when you do web application and all that much. Actually, even web application, they do that nowadays. Serverless application, every call that you make, it gets created, right? There's a warm-up time. And in JVM, we'll have warm-up time. And then on top of that, you have this preparation stuff also. That is quite costly, right? The startup time related activities. That is one problem that we face. In order to solve this problem only, nowadays, there are few tools. In fact, for dependency injection, there are people, there are database, there are two people. So what everybody is trying to do is, they are trying to go with static typing or compile time preparations. So what happens in compile time preparation is, let us go to the previous one. So it's not like it's like trend only. Even in fashion, you will have this trend. Something that was a trend in 80s, it will come again in 2000. So it's a round, right? Similarly, now in some case we are actually going back to this factory pattern only. Only thing is that you have the advantage of this, but you don't create the factory yourself. The factory is being created by someone else. But the key here is, this factory is created right at the beginning, that is at the compiler time. Let us just consider what does that mean. Okay, these are all the objects. So as I told, the most powerful feature in object-oriented world is the new operator. So we want to hide that as much as possible, so that the power comes with proper responsibility. Now, for example, let us consider vehicle module. If you want to create this as a vehicle module or vehicle component, when you say @component or @inject, @provides, when are you making the decision that this is supposed to be injected? You are making that decision right here in your IDE. Now in Spring case, what is happening is, now this project should get compiled, the binary gets created, the application gets started. At that point in time, Spring decides it. But if you just logically consider as a developer, come on, I am saying inject this here. Better you inject it before even you do the preparation, so that at runtime, it should be just run it. It should not just do any decisions or preparations at runtime. If you are adamant on that kind of a performance, probably that is the time that you need the static dependency injection frameworks. So first, bottom line, if you are familiar with familiar with Spring Boot, there are one slight adjustment that you need to do. As I said, here your injection happens during, not at the time of starting the application. It's time of compiling the application. For example, now let us look at the external world perspective. This is how static DI works. Okay, now you go here, you'll see the compilation error. And let us look at our model here. So here you need vehicle module. You are building vehicle module, and through that you are going to build a car. And that car has dependencies like engine and brand that you want to provide it to the car. And that's what you are saying here. You say provides. And just for our information, these dependency injection, Dagger uses Java inject. This is basically a common standard way of using dependency injection. Even Spring respect this. You can use the same annotation instead of auto air, instead of component and all this stuff. You can use it from here also. That's the thing. Now, so the compiler will complain. The reason being, the magic will happen when you compile it. For example, now I'm doing Maven clean package. Now what is happening is, this will have its own compiler. For example, if we are using a solution called Dagger, Dagger has a compiler. What Dagger compiler does is, it scans your code during your build time, and then sees, okay, there are modules, there are components that I need to create, and then build every dependencies. Now you see the compilation error is gone, and the test case runs successfully. But the magic here is, now you can ask this question, you are generating the code, will it not create any confusion, because somebody else can modify this code. And the beauty here is, it will not create the code that you can commit it, but rather this particular code that we are talking about. See, now this class is generated, but this class is generated not inside your SRC folder. If you are familiar with generated sources concept in Maven, in your target folder, you can see this generated sources, where there are a lot of frameworks that generate sources behind the scene. You can just open this and then see, for example, now Okay. Yeah. So these factories that you see, right? These factories are created right at the compile time. So this is what we were discussing actually. Now here, everything that you do is created at the compile time. Now what happens at the runtime? See, now what do you mean by runtime? You just check the classes folder. In your classes folder, finally, this is what packaged as a jar, right? You see your classes, you see your factories all packaged well inside your jar. In that way, at runtime, we will not have any prep work. It will just shoot, it will run. So it looks like a clear advantage, correct? Anybody sees any disadvantage here? Looks like modern technology. Actually, this is there for quite some time. Not many people use it, surprisingly. But now with the awareness of serverless Android applications, now people are started using this. But at the same time, whenever a new technology comes, we will always have that mindset that okay, now new person has come, so we need to deprecate the old person. No, static and runtime dependency injection has their place for different use cases. Even today, it's not like we got Dagger, we will just come out of Spring. No, Spring has its own advantages, its own use cases actually. So now, beyond a point, you cannot add more often. There are two noticeable disadvantages that I see. One is if you are coming from Spring world, you will have some cleanliness in your code. For example, what you would expect is you want to inject this. You want to inject it not as a constructor, but rather sometimes you inject it through this also. Okay, that kind of facility you won't have, because if you run it now, you will see that private fields cannot be injected because it's not like in Spring World it can create a dynamic proxy. Here it cannot create a dynamic proxy, so it will not allow you. It will say it will not allow private fields. So in some case, and apart from that, if you just look at the code base, so consumer side, so consider you are using Dagger. Your final, when you implement this code, the code is going to look something like this, which means you have some code which looks slightly unfamiliar to you. So the code cleanliness will not be there. That's one thing that I see. But of course, it comes with a better benefit of performance. It's not like everything that you do with Spring, with adding dynamic behavior and all this stuff, you cannot do it here. So if you analyze the nature of your dependency injection, and you think that it is static or dynamic, you can make choice between these two frameworks actually, and they go well on their own use cases. So that's about Dagger. Any doubts? Any questions?
There are a couple of questions, Satish. One is that from Girish, that is, how is Dagger different from Quarkus, which is a Kubernetes native framework for?
Okay. So Quark, again, as I told, nowadays the modern frameworks are trying to use this technique. Quarkus is basically an enterprise application framework. You can compare Quarkus with Spring Boot. I think Vertex also you can compare. In Scala, you had a Play framework. So Quarkus is that kind of an umbrella project. So that uses compile time as a technique. At the same time, for dependency injection, Dagger is very simple library. It's a very small library. So for dependency injection alone, it is used. So in a sense that Quarkus is a framework that has lot of other things also. Dagger is just simple dependency injection in its own way. That's it. It's a simple library.
Okay, another question from Naidu. Okay, I'm sorry if I'm pronouncing the name incorrectly. That apart from startup time, does Dagger provide any other advantages? As in, because we are doing compile time dependency injection, apart from startup time, what other benefits are there?
Correct. So there are a lot of advantages. It's like the choice, right? You decide to do it at the compile time. You can do some compile time checks and all those stuff. There are a lot of advantages that we'll see in detail. But the answer is yes. It's not just about startup time. There are a lot of other advantages also. So just consider that at the bottom line, you made a decision of whether you are going to take a runtime route or a compile time route. Compile time route has its own advantages. You can do a lot of type checks, a lot of stuff actually.
There's a follow-up question from Suraj, which I think is related. His question is that can we replace a Spring code with Dagger in Spring Boot project?
Technically, you can do, but it's not advisable to do, because if you have taken Spring route, Spring core is anyway part and parcel of your umbrella project. It's one of the most bottom line dependencies. In that case, from an experimental perspective, yes, Suraj, you can do that. But if you ask it from practicality or code cleanliness or good principles, it is not advisable. But you can do it, because ultimately it is just a plain Java, right? And the moment Dagger completes its work, It's all your own code. You can use it anywhere. That's what you need to consider.
But I would the only observation I would say is that it's like you're kind of getting into the unknown now, because you're trying to do a transition of control between Spring and Dagger continuously. So you need to figure that part out, or rather be aware of it.
No, that is a thing, right? That if you understand this clearly, what Dagger does is it just build your Java classes. So the right at the time that your Java classes are built, that is, these are all the classes. It is no longer Dagger actually. It's no longer Dagger actually here. So if you look at it, it's no longer Dagger. So you can still do it. It's not, Dagger is not doing a lot of things, right? It generates most of the things as your code only. You can still do it, but it's not advisable. So as Sanjay said, yeah, you need to do a lot of rewrite. Rather, you need to look at something like this actually. Thinking it from Dagger or thinking it from Spring perspective. If you think it from Spring perspective, Spring provides a lot of things if you're using Spring platform. So those features you might need to compromise if you are trying to bring these two together. For example, where it fits ideal is command line applications, serverless applications, UI applications. If you are building them, then in that case, Dagger is an ideal choice actually.
You're saying that because we are going to serverless and we're going to do like low power machines.
Yeah.
As much of it compiled is ready.
Correct. And these factories that it generates are highly optimized also. So rather you hand code the factories, you get both the world's advantage. That is previous world creating a factory, a new world less amount of code. Dagger does both. So now if that is the case, I'm not going to make two different tasks actually, even though it looks like two different tasks. We will always keep it as a follow-up so that we can learn better as a focused item. Yeah, so as Sanjay pointed out, in Spring, Lambda functions are kind of slow to start up actually. It's not slow. It's about we are using a wrong solution for a problem actually. That's how we should consider. Okay. Now we are going to go to just the next step now. Okay. Now, okay, there are dependency frameworks. There are runtime dependency framework. There are compile time dependency frameworks. Are we done covered? We don't need to think about factory patterns anymore. No, still you need to think about factory pattern in case if you are doing something apart from writing just a delegate, controller, service, these kind of enterprise applications. If you write something at the core level, library level, then probably you need to go one step further. And that is what we are going to see with what kind of design pattern that it solves. So last month I had an interesting problem. So that time I thought, okay, I will share that problem with the team also, because I found something useful in dependency injection. So that is the next step. Shall we